This example says that a 75-foot tower is located on the side of a hill, and that hill is inclined 26 degrees to the horizontal. A cable is then attached to the top of the tower and anchored uphill a distance of 35 feet away from the base of the tower. And we need to find the length of that cable and round to the nearest foot. All right, so we can see here we've got our flat ground. And here we've got our side of our hill. And we can tell that in between the two is a 26-degree incline. We can also see here at the base of the hill that we have our 75-foot tall tower. And here we have the cable coming from the top of that tower being connected uphill 35 feet from the base of the tower. And we need to use this information to find the length of the cable, which we're going to let be the variable c. One thing that's important to notice here is that the angle formed between our tower and level ground has to be a right angle, or 90 degrees. If it weren't, we would be working with the Leaning Tower of Pisa here. So we know that the angle formed by the flat ground and our tower is a 90-degree angle. And if that's true, then this angle must be 64 degrees. Because the two angles together, 64 and 26, have to be complementary. Now I have two sides of a triangle and an angle included between those two sides. With that information, we can use the law of cosines to solve for c. Using the law of cosines, we have c squared is equal to a squared plus b squared minus 2ab times the cosine of c. Now, obviously, we're going to have to let this angle be angle c because it is opposite side c over here. And the truth is, it really doesn't matter which angles we label angle A and angle B at this point. All that matters is that we know that side A is opposite angle A. So 35 feet would be side A. And angle B has to be opposite side B. So side B would be equal to 75 feet. And that would give us A squared, which would be 35 squared, plus b squared, which is 75 squared, minus 2 times 35 times 75 times the cosine of angle C, which is 64 degrees. 35 squared plus 75 squared is 6,850. And minus 2 times 35 times 75 is minus 5,250. And we still have times cosine of 64. And a little bit of calculator work tells us that the result of 6850 minus 5250 times the cosine of 64 is 4548.55147 9. Now I'm taking this out to as many decimal places as possible so that my result is as accurate as possible. Now this is c squared. To find c, we just take the square root of both sides of this equation. So now we need to take the square root of this 4548.551479. And when we round that result to the nearest foot, we get 67 feet. So the length of our cable would need to be 67 feet.